All right, good morning. Welcome to InstructureCon. It's awesome to be the first guy up. It means I get to enjoy the rest of the conference. So I'm going to be telling you a story today in 3 acts about how Simon Fraser University implemented and scaled up open source Canvas. We're going to talk about a few things. We're going to look at the production start guide and how you can go beyond it, how you can keep up with Instructure's release cycle, and some general care and feeding tips to make sure your Canvas is nice and happy. Before we get started, this is going to be a pretty high-level talk. We've only got 30 minutes, so we're not going to go too deep into any one topic. I'm going to be around at the Hack Night tonight. I've got 2 of my colleagues here as well, so if I can't answer your question afterwards or if there's something I don't cover, please come and find us, and we're more than happy to share what we've learned. This is also what's worked for us at SFU. There's tons of different ways you can implement Canvas. This is what's been, in our experience, and we found worked. And hopefully you can take some of this back to your institution and make it work for you. And it's still evolving. We're always finding new ways to tweak this and make it even more efficient. So Simon Fraser, we're in Vancouver, BC, and we're a mid-sized comprehensive university. We've got about 30,000 students, 6,500 faculty and staff. And we love Canvas. We're big fans. We previously were a WebCT shop. We were a WebCT shop for years and years and years, right back to when it started just down the road at UBC, and it was a Perl application. And we've been using it for a really long time. And we got notice from Blackboard that said, we're going to be end-of-lifing this thing that you've been using for way too long. You need to get off of it. We're going to turn it off. So we started looking around, and we did a whole RFP process, looked at all the usuals. We looked at the ones you'd expect, the corporate ones like Blackboard and D2L, open source ones like Moodle. And partway through that process, we heard about this thing called Canvas. We hadn't heard of it before. So we spun it up and played with it, and we went, oh, this is pretty cool. And the rest of the selection group looked at it and went, this is pretty cool. And a very rare thing happened in academia. We had unanimous support for it from across all campus groups. Everyone wanted us to go with Canvas. So we did. This was our implementation timeline. Pretty rapid. We went from 0 to 25,000 students in 5 terms. So right from selecting Canvas in the fall of 2012, we jumped right into a pilot phase the next term with a few credit courses. So these are actual live courses. Into a co-production phase with WebCT. So we were running 2 systems in parallel at that time. And during that time, we exceeded our peak WebCT usage. We had more courses in Canvas than we'd ever had in WebCT before. So yeah. We blew away our WebCT usage within the first couple terms, and we weren't even in full production yet. The last term, spring 2014, just ended in April. That was our full production term. WebCT was retired, shut off. We had just over 24,000 students, just under 1,000 courses, and just under 1,000 instructors on it. And we did it all with a really small technical team. This is us. There's 3 of us here. There's a few more back home keeping things running. 7 of us, including our team lead, business analyst, developers, operations guys. And we had some support from our shared infrastructure groups for storage and database admin. And none of us work solely on Canvas. We're all working on at least one other major system, whether it's our email system, which is also an open source product, or our content management system for our web stuff. So we're all splitting our time between all these different tasks. And so you might be asking, why did you go open source? Why didn't you just use the cloud version? And for us, it wasn't cost. We're paying 7 full-time employees to keep this thing running. The main reason for us was a legal one. British Columbia has very strict privacy laws that say we cannot compel students to use non-Canadian hosted services. So that means anything on Amazon is out. Anything on Google is out. We can't compel them as part of their courseware to do it. They can opt in if they have informed consent, but taking a credit course where it's the only thing, the online option is the only way to do it, that's compelling them to do it. So we had to go open source and run it ourselves. And we've got a long history of doing that at SFU. We run lots of open source products. We do in-house development as well. So it was kind of a natural fit for us. So show of hands, who here's ever installed open source Canvas? Okay, keep them up. Who is running it in a production environment? Yeah, non-Instructure employees, non-SFU employees. Who is looking to do it? Okay, good. So you've probably seen this production start guide that Instructure has on the GitHub wiki. It's a very thorough document. It will walk you through installing the open source version of Canvas in a production environment. And it's great. We used it when we were going through the whole setup process. But it makes some assumptions that may not be accurate for your environment. For example, it assumes you're going to be using Ubuntu, specific versions of Ubuntu. We're not. We're a Red Hat shop. All of our core Linux stuff is on Red Hat Enterprise Linux. So we had to figure that part out. We kept detailed notes. We tried doing Ubuntu. We found it was easier to get it running on Red Hat, probably because we just had the experience with it. We had deep technical knowledge of Red Hat from our Instructure guys. So you got to keep that in mind. The production start guide's not the end-all and be-all. You can go beyond it and kind of tweak it to be what you want. The guide makes mention of having multiple servers, but that implementation is left up to you to figure out how you're going to do it. And you could install Canvas on one machine, serving Rails, web stuff, database, delayed jobs, Redis. You don't want to do that. You have no redundancy. If something goes wrong, that's it. Your one machine is gone. So what are you going to do? How do you take that guide and scale it up to what we call real production? The first step is to own the code. The production start guide gives you instructions for deploying from the Instructure GitHub repo. I'm going to tell you not to do that. What we did is we created our own GitHub organization. So we're github.com/SFU. We forked that repository, so now we have a complete copy of that repo. There's no connection between the Instructure one. It's our code. We can do whatever we want with it. Step 3, step 4, except it's open source, so there's really no profit in it. Why would you want to do this? Well, like I said, you've got a copy of that code now. So if Instructure becomes evil, they get bought by Blackboard, or otherwise goes rogue, you've got that code. You can do what you want with it. You can continue to run it. You're not beholden to them or that repository staying alive. And you can make modifications to the code if you want, and not have to deal with putting them back when Instructure updates their repository. And you can contribute code back. One of the great things about open source is if you see something you want to change, you got a feature that's not there, you can easily build it in and try and submit it back. And if that interests you, I would encourage you to go check out my colleague Andrew Leung's session tomorrow. He's going to be talking about how you can do that. We've put a lot of pull requests back into Instructure. Andrew's probably had the most of them, and most of them have been accepted. So check that one out tomorrow. So back to separation of concerns and having multiple servers. Like I said, you could do it all in one box. Probably don't want to do that. This is us. This is SFU's Canvas infrastructure. So we've got a load balancer at the top. We've got what we call the app nodes, and we've got 8 of them. They're in a pool in our load balancer, and those are what serve user-facing requests. So when you go to canvas.sfu.ca, you're hitting one of those 8 machines. The 7 next to it are what we call the file nodes, and those handle our file domain, so files.canvas.sfu.ca. And so anytime you're doing a file upload or download, it's hitting those boxes. We had them combined at the start. We have some pretty file-intensive courses, so we decided to split them out, and we saw a better distributional load between them. So the management nodes off to the side, there's 2 of them. Those are where we run our delayed jobs. They're not in any pool in the load balancer, and they're not serving any traffic. So we're doing delayed jobs, we do our overnight enrollments, CSV enrollments, and things like that on those machines. Just keeps the load off of the user-facing machines. And we've got 5 hot spares. Just sitting there, they're VMs. All of these are VMs. They're all configured identical. They have the same code. So we've got 5 of them just sitting there in a ready state. And if we get a sudden spike in traffic, we can just dump them into any of the pools, and it helps scale it out horizontally. And we've got a bunch of shared infrastructure underneath. So we've got shared storage. Canvas out of the box uses S3 to host the assets. Again, we can't use Amazon stuff. So we've got mount points from our NetApps on all the machines. We're using Postgres. If you're using MySQL and you haven't heard, you should probably stop using MySQL for Canvas. They're going to be taking that out real soon. We're pretty happy we went with Postgres from the start. And then Redis cache. Canvas makes extensive use of caching. It says it's optional. It really isn't. If you want to find out that it's not optional, turn it off in production and see what happens. You'll see your CPU start to go way up. So that's us. That's our infrastructure. So we've built it up, it's running, and like any software, you probably want to keep it up to date. Instructure has a release cycle, and they're always working on the code, they're always improving it, and it's a versionless system. They're not putting out this is the 1.0, this is the 2.0. They're just pushing code. It's like a fire hose of code, and you want to keep up to date with it. And to do that, you've got to understand the Instructure release cycle. So Instructure pushes a new release every 3 weeks on a Saturday, and then they do incremental hotfix releases in between. They put all the releases on GitHub. They tag them with a release tag. So this is the May 3rd release, and you'll see that .12 at the end. Before it, there's a whole bunch. After it, there's a whole bunch more. So as they're working on it, as they're working on whatever code is going into that release, they're releasing it through their system and then ultimately out to GitHub, and it gets tagged like this. I haven't found a way to actually figure out which of these tags is the one they're pushing to production on any given Saturday. I know there's some Instructure folks at the back. If you can help me with that, talk to me after, because right now we're just kind of picking one when we do our merge. We just say, this one looks good. Let's try that and see what happens. So if you can help us out there, that would be awesome. So that's Instructure. At SFU, we wanted to keep up with it as well. We wanted to be in sync as much as we could with Instructure. Just so when we do upgrades, we're not doing massive upgrades. We're just doing these little incremental ones, so we're not making huge changes. So a similar 3-week cycle. I couldn't find an animated GIF of our mascot. He's a Scotty dog. So we have a same 3-week cycle. We do ours on Friday, and we stay one release behind the cloud. We let the paying customers be the guinea pigs. So if on May 3rd, Instructure did a release of their May 3rd release, we did the previous Friday, we did the April 12th. And then 3 weeks later, we're doing the May 3rd release. So we're just one release behind. And so it's a pretty crazy cycle. I mean, some of our other systems we might touch once every year or two, and they're major point release kind of things. So this was a new experience for us. So we had to develop some workflows for doing it. The first thing we did is we decided to go 3 branches in our GitHub repo. We have the first one we call Edge. That's our bleeding edge branch. It's where SFU code and Canvas code meet for the first time and start to get to know each other. And that's where we pull in. When we pick that, we just reach into the bag of release tags and pull one out and say, this is the one we're going with. That's where we put it in first. We do some technical testing there, and then we push it into our develop branch. And that's where our developers do our development. We're doing stuff on Canvas. We've got our own plugins. We're sometimes modifying core code. So we do it all in that develop branch. And then finally, we've got the deploy branch, and that's a clean branch. That has to be clean, must be deployable to production at any time. So if we have to spin up a new VM, push code to it, that branch is it's our master, it's clean. And so a process kind of goes a little bit like this for getting stuff in. Like I said, first we got to figure out which release tag we're going with. So usually on the Monday after we do a release, we do our release on Friday. Monday I come in and I just see which is the most recent one from the release we're going with, and I grab that one. I pull it in, and I start a merge, and it goes kind of like this. And it's really hard for you to see on this screen that there's a huge block of red text at the bottom of that screen. Those are merge conflicts. Those are merge conflicts in files we have never touched. I can guarantee you I've never touched the Turkish language localization file. And this is something we've been trying to battle with for a while. So again, if there's anyone from Instructure who can give us a hand, we're probably doing Git wrong because the default state for using Git is to do it wrong. So every Monday I'm always just going, yep, this one's theirs, this one's theirs, no, that one's ours, this one's theirs, this one's theirs. So again, find me the hacknet if you can help me figure this one out. So once we've got that merge resolved and it's up on our Edge cluster, we start doing our technical tests. And these are pretty quick. It's really just, does all our stuff still work? Do our mods work? Do our plugins work? Did all that stuff come through cleanly? Did we have a bad merge? Did I accidentally clobber one of our mods when I brought in an Instructure commit? After that, we release it for functional tests. Those are our partners in the Teaching and Learning Center, Center for Online Distance Education. And they're looking to see, does all of their stuff, does all of Instructure's stuff still work? Is everything working as documented? Do we need to change documentation? Do we need to generate new documentation because there's new features? How do these new features work? And once we're all satisfied, we get a go, we push it to production, and then we start the whole thing again the next week. So it's a pretty rapid cycle, and we've tried to automate it as much as we possibly can just to keep some semblance of sanity. And we use a bunch of different tools and techniques for that. I talked about GitHub earlier, the context of forks, so we have our fork. And our developers have their own forks as well. So we've got the Instructure repo forked off to SFU, and then I have github.com/grahamb/canvaslms. That's a fork of the SFU repo. And that's where we do all our development. We do it in those forks, and then when we're, say I'm working on a new feature or a bug fix, once I've satisfied it's ready to go, I will do a pull request into the SFU repository. And then it goes into our admittedly fairly lightweight code review process. Our policy is that any code we're putting in has to get looked at by 2 other sets of eyes, so not the person who wrote it, and they've got to give a thumbs up in the GitHub comment. So 2 thumbs goes to production. And that's a horribly blurry photo of what it kind of looks like. This was a pull request, and it's going through the code review process, and we've got comments happening on individual lines of code saying, is this the right way to do it? Can we do it a different way? I think this is a bug or whatever. And it's been working fairly well for us. Bamboo is our continuous delivery and deployment system. It's what we use to do our deploys. It handles a bunch of our different production systems. Kind of looks like that. It just gives us one-click access to doing a deploy. So I could right now, if I was insane, go to Bamboo and hit the deploy to production, and it would just start spitting code out to all our production servers. And it gives us one place to look for the logs for all those deploys. If there's any failures, it'll show up there and start alerting us that a failure happened. Capistrano is a remote server automation and deployment tool. It's written in Ruby. It gets used a lot for Ruby and Rails applications. You can use it for anything, though. I use it to deploy Node apps as well. And it just basically runs code in parallel on many servers over SSH. And it uses recipes to do it. So you define a recipe or a task, and I say, so this task is the load notifications task. It runs this command on every server to do this thing. And Capistrano just runs these in order in parallel. So Bamboo checks out the code and just says cap deploy. And that just starts the process of spitting out code to all the servers. And it gives us versioned releases. So it deploys into a date stamp directory, and it just moves a symlink around. So it gives us the ability to roll back to a previous release. So if something goes horribly wrong, deploy fails, we can just roll it back, and we're right back where we started. Fusion Passenger, if you've installed Canvas, you're probably familiar with it. It's the app server recommended in the production guide. It has an open source version, and we were using that for quite some time. We decided to end up going with the enterprise version for a few reasons. One of the big features in the enterprise version is rolling restarts. So you probably restarted Canvas before, and it takes a little while for it to start up. And when we're doing updates, our previous method of doing updates before we went to this was we were doing them at 10 o'clock at night. We would put up a we're closed, go away page, do the deploy, because it would start up and it would take a couple minutes for it to come up. And we didn't want students to be left hanging while that was happening. The enterprise version does a rolling restart. So as it shuts down workers, it starts up new ones, and there's really no downtime visible to the students. This has enabled us to do deploys at noon on a Friday, which is awesome because all the staff are in the office. Oops. Finally, this is our junk drawer. Us or local Canvas is a mount point we have on all our machines. It's the same on every machine in any cluster, whether it's our test cluster, our production, our staging cluster. And it's just it's a place for us to stick stuff we need on all those machines, including our configuration files. Config files are one thing you don't want to have in your GitHub repo because they probably have credentials in them. You don't want your database credentials sitting on a public repository somewhere where someone can get a hold of them. So we put them all in here. They all have a prefix on the file name that says it's the production one or the test one or staging one. And when a machine boots up, it runs a script, looks at its host name, determines, oh, I'm a production machine. I need to go grab all the production config files and put them in the right place. That script runs during a deploy as well. There's other utilities on there that give us the ability to run code on every node or get stats from Passenger, things like that. OK, so the last part, you've got it installed. you're updating it on a fairly rapid cycle. You need to kind of keep this, you need to keep this thing running. It's a production system. Your students are using it, your faculty are using it. So how do you keep your Canvas happy? This was the huge win for us when we did Canvas. We have a lot of experience at SFU keeping large, complex apps running for tens of thousands of people. We had zero Ruby on Rails experience. There's one guy in the office who wasn't on the Canvas team who'd used Rails before. That was it. The Canvas team had nothing. So sticking with what we knew let us concentrate on what we didn't know. So that's why we decided to stick with Red Hat instead of having to go with Ubuntu. Sticking with Apache instead of using Nginx. We have experience in all those things, so we could spend our time building up Rails experience, figuring out how Canvas worked, figuring out the Ruby ecosystem. Beware core mods. I mentioned Andrew's session earlier about being able to contribute code back to Canvas. One of the awesome things about open source is you've got the code, and you can modify it, and you can make it do whatever you want. One of the terrifying things about open source software is you've got the code, and you can modify it, and you can make it do whatever you want. Once you do that, you own that mod. It's yours. And if Instructure comes along and stomps all over it, you've got to figure out what to do about it. So before you go down the road of touching core code, you want to ask yourself, can I do this with the API? Can I write an LTI to do it? Can I even use custom CSS or JavaScript or a vendor plugin or whatever's replacing those in Rails 3 and 4? Sometimes you might be able to do it with one of those tools. Sometimes you might actually just have to get in there and get your hands dirty in the core code. And if you're going to do that, it's a really good idea to reach out to Instructure, to the community, and say, this is what I want to do. Are you guys considering this already, or would this be something you consider as a pull request? Because a lot of times they either are considering it, or it's something they would consider bringing in because it may have a benefit to the greater community. And if they do that, it's awesome because then it's their problem, it's not your problem anymore. All right, finally, keeping an eye on things. It's a production system, you've got to monitor it. We use a bunch of tools for this. One of our main ones is Xymon. It's your bog standard systems monitoring tool looking at CPU and memory and disk and things like that. And it has custom probes. We have one that looks at the number of failed jobs in the delayed jobs queue and will alert us if that gets above a certain level. It's ugly. Fortunately, we never really have to look at the UI for it. We use it to get email alerts and stuff, so if a system goes down, we get paged. Logstash is a log indexing and searching tool. Canvas puts out a lot of log output in a couple different places, and there's a ton of information in there that can help you. It's really hard to dig through that information. So Logstash takes that, it will parse it, it can sort out, you can give it custom queries, and it will sort out interesting metrics. And that's all we're really using it for right now. We're doing pretty light use of it. And mostly we're taking the metrics we care about out of those logs, and we're feeding them into our Graphite and StatsD system. Graphite's a system for storing and rendering time series graphs, and StatsD is just a really thin daemon that sits on top of that aggregates stuff and gives you some extra types of stats that Graphite doesn't natively support. And Canvas has built-in support for StatsD. There's just a comp file you modify, you put in your StatsD server, and you're off to the races. All of these feed into dashboards. We are addicted to dashboards at SFU. We love them. We've got them everywhere. We use a framework called Dashing, which is from the folks at Shopify. And it makes it fairly easy for you to create custom dashboards. This is our Canvas dashboard. It's sped up a little bit. If blinking lights bother you, you might want to turn away. So this is our main Canvas dashboard. This is actually running during one of our deploys on May 2nd, so I was deploying the April 12th release. And this is why it's starting to go red. So we get CPU monitors and passenger queue monitors for all our production app nodes over on this side here. We've got graphs coming out of Graphite for things like hits per hour for Rails and Apache. We've got some stuff coming out of Google Analytics at the top, the active web users. This was a really slow day. That's coming out of Google's real-time API. And then other things like just GitHub stats and our Bamboo stats. And these have been really useful for us. We've got them everywhere. This one's on a giant TV in our common area. It's right by where we all eat lunch. We all walk by it on our way to our offices. It's right outside the boss's office, which is not a great thing sometimes. But it's nice having that visibility. So as we're just walking by, we can say, oh, there's 4 nodes and they're all yellow. Something's probably going wrong. We should take a look at it. And most of our developers have them too. This is my desk, so I've just got it up on a spare monitor to the side. So it's just in the corner of my eye, so while I'm standing there typing, I can see if something's starting to go wrong. All right, last thing, getting help. Canvas is pretty complex, Rails is pretty complex, and you're probably going to run into some problems. And it's good to know where to get help. These are the 2 main resources that you want to be paying attention to. If you're not on these already, get there. The Canvas LMS channel on Freenode on IRC is awesome. There's a wealth of experience in there. There's open source users, commercial users, technical people, non-technical people. It's great. And there's Instructure engineers in there too. And it's a huge thank you to all those Instructure folks who hang out in there. It's really nice being able to talk to someone who actually wrote the code you're having a problem with. Same thing for the mailing list. They're both really great resources. And if you're going to ask for help, know how to ask for help. This is almost verbatim a message that came into the Google group a month or 2 ago. Can't help you. I'm sorry. If you're going to ask, give us a little bit, give us something to work with. So know where your logs are. I mentioned them earlier. There's tons of logs. They can be in different places depending on where you've installed them. Know where they are and look at them. If you're getting errors, watch the log while you're doing the thing that's generating an error. You'll probably see what's happening. The /error reports URL is also really good. On open source, you have access to this. On cloud, you don't. And this is a nice interface for looking at errors. And it's searchable. It's server errors. It's client errors. If a JavaScript throws an exception, it's going to be in there. This is really great. OK, so that's the end of the story. Like I said, this is what's worked for SFU. This is our canvas. Many are like it, but this one is ours. Hopefully there's some things you can take out of this, take it back to your institution and work it in. And hopefully you'll be up here presenting next year on what you're doing to scale open source. And that's it. That's how you can get a hold of me. I'm going to be at the Hack Night tonight. I think all of us from SFU are. So if you've got any questions, come and find us. We're more than happy to share what we've learned from this. That's it. Thanks.
We have 1 minute for questions. Does anyone have questions? If not, that's totally cool, but okay. It's going to get recorded.
So all the nodes you showed were your current infrastructure. What did you start with?
So this question, just in case you couldn't hear it, you wanted to know the number of nodes we originally started with. So yeah, we've got 22 nodes now, which including the hot spares. We started with 3 and 1 management node. So 1 offline node for delayed jobs and 3 user-facing jobs or nodes. We did some load testing initially, and we found we could hit 300 concurrent users on each node, so 900 total. Concurrent's a little weird in Rails because it's stateless. You hit a URL, you get something back, your session's done. But that's where we were finding we were hitting before we got really high I/O. And then we just had to scale it up from there. That was during our pilot phase. So it's we've got lots of headroom with that configuration. It doesn't spike up too often. Usually there are a couple heavy courses that do file uploads and downloads a lot, and we'll see spikes on that. But usually it's very low CPU, it's very low memory, it just kind of hums along. So you can get away with less. VMs are cheap, so when we have a large VMware infrastructure, so we just have spun a bunch up.